Thanks to be here for this talk about zero-downtime deployment. I've been asked whether it will be a lot about Java and Spring and whatever. Well, the whole beginning is completely abstract, talks about the concept, Kubernetes a bit. Then, of course, afterwards I have a demo, so I will need to show some code. But the whole beginning can be applied anytime, anywhere. I'm Nicolas Frankel. I've been a couple of times in Ukraine, in Kiev already. I've been a developer for a long time, architect or whatever, as a consultant. Recently, I changed my career, and now I'm a developer advocate. When I was a consultant, and still I'm interested in like DevOps, what happens after you actually finish writing your application? Who here is a developer? Quite a few people. Who here is an ops people? Okay, who here is DevOps, whatever that means? Okay, couple of people. I work for a company called Hazelcast. Who knows about Hazelcast? A few hands, okay. So you probably know us for our IMDG, in-memory data grids solution. So basically caching, or I prefer to say like distributed data structures, because we don't only have like maps, key value stores, but we have queues, we have logs, we have longs, we have whatever you want. But we also have something called Jet, which basically builds upon IMDG and is about stream process. If you have questions, or if you want stickers, come to me afterwards. Now, why zero downtime? Who here already has zero downtime deployment? Wow, that's a lot. Why are you here? You already know everything. So the first reason why you might want to go to zero downtime is because, well, wouldn't it be cool if we wrote down like zero downtime on our resume? That would be cool, just as you would write DevOps, microservices, Agile, Kubernetes, whatever you want to be like. You want to be hired, so basically you write down those keywords. So you should at least pretend you implemented them. So first reason why you want zero downtime is because you, as engineers, want zero downtime. Second reason is people are getting used more and more to having no interruption. I'm quite old now, and when I started working, when you wanted to upgrade your application, you just like change the proxy, like redirect every single request to a static web page. Hey, sorry for this downtime, but we are like upgrading, and everybody was used to it. That was okay, especially if it's an internal application. Now we have more and more external application, and moreover, we have Facebook or Gmail or Amazon. When was the last time that you actually went to Facebook and saw this page saying, hey, sorry, we are down for a few moments? Never, never. So your grandmother or your grandfather, they both use Facebooks, they don't understand when somebody tells them, hey, the app is not available. And the third reason is mostly it's about money. Like I've worked in e-commerce before, and in e-commerce, you want to sell all the time. So when basically you bring your app down to upgrade it, or for whatever reason, you don't sell, and customers, they go to the competitors. So that's a net loss of revenue. You don't want that at all. So for all those reasons, you might want to go zero downtime. But come on, everybody knows about zero downtime. We have been doing it for years. We have Bluegreen deployment. Who knows about Bluegreen deployment? Yeah, most people know about Bluegreen deployment. So basically you have two different environments, one blue, one green. And so now green is production environment. So the user, they are directed to the green environment. And meanwhile, you just update your blue environment with the new version. And when the time is right, switch. And it's done. I mean, that's a dream. You already have it. It has been described many times. Of course, among you, there might be some people that actually read the diagram and tell me, hey, but what about the database? What about the database? Here we just need to copy every data that was here. Okay, that's easy, then just have a single database. I mean, I've been an architect, this is what we do. Just arrows and everything is fine. But if we dig a bit further, actually, there might be like real problems behind Bluegreen deployment. The first is the routing latency. Here is just like saying, oh, the arrow just switches. Actually, in the real world, it just doesn't work like that, because some users might be on different proxies, and so they might still be redirected to the green environment, and not all users will be directed instantly at the same time to the blue environment. That's distributed systems in action. Second is, what about the users that are actually using the environment? What about them? What should you do about them? Just like kill the sessions or whatever? And the third problem that I already mentioned is the management of the database, and it all boils down to state. So either you just try to instantly copy the data from one database to the other, or you have one single database. And then you need to be able to make sure that the changes in the schema are compatible. Unless you are using, I don't know, like NoSQL database, because everybody uses NoSQL database, right? Of course, no, really. You should put it on your resume. And Kubernetes comes with this new principle saying, hey, let's do rolling updates. So you have 3 nodes, because like in my stupid example, I only had 1 node, but then we have multiple nodes in real applications, and then you just, one by one, you upgrade them. And it's very easy. We have this object in Kubernetes called deployment. So you just tell it, hey, like I want to do rolling update, and then you have a couple of like parameters. The first one is like the max search, so how many additional containers you are allowed to bring up, and how many max unavailable is the opposite. So how many how many pods are you allowed to bring down? So if you want a graphical view of that, let's imagine you have 3 replicas, like in my first example. So of view 1, if you have max unavailable 0, max surge 1, that means you can bring 1 extra pod here. So it will say, oh, I have 3, I can go up to 4. I will like spin off a new V2. And then because I can go down to 3, I can remove one of the old one. Then I spin off a new one, then bring one down, blah, 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 until I get all of them are V2. Or if you don't have that much money, because that requires extra infrastructure, what you can do is basically you can like first try to remove one of the old ones. So you can, from 3, you go back to 2, and then you spin off a new one of V2, and then 1 again, until all of them are V2. And if you can play with both, then you can be much, much faster. So you might think, okay, looks nice, but actually the apps, they don't start instantly. So the pods actually needs time, especially if you are using Java, which brings the JVM, which is, as you probably know, not instant startup time. So we need to know when the pod is actually ready to service requests. If you are using Spring Boot, we have something called the actuator. If you don't use Spring Boot, you need to write down your own. But basically, you can like wire something called the readiness probe into your container. And then your application tells, hey, I'm ready to service requests, send them my way. And then Kubernetes will tell, oh, this app is available, let's send requests to it. And it's, I mean, and at the end of the talk, for most talks, that it ends there. But if you really thought and listened to me, I told about the problem was about the database. And all this Kubernetes stuff is not its problem. State is not a problem. It works very well for stateless apps. And among you, who has only stateless apps? Yeah, that would be the dream, that would be the goal, but actually there is like state in the database, there is state in the session, there is state everywhere. So yes, it's easy, functional programming for the win, but what about the state? We must handle the state somewhere. And so basically now if we bring on the database and I do the rolling upgrades, what will happen is the following. And afterwards, it doesn't work anymore. So basically, we cannot allow ourselves to upgrade the database when you have incompatible schema changes. Conclusion, consecutive app version must be schema compatible with each other. So basically, your app 2.0 needs to be able to work with database schema 1.0. Works for you? Okay, let's do it. So now we have this 1.0, we start the rolling update, so we like upgrade all the nodes and everything is finished, then we migrate the database. Works for you? Yeah. And then, of course, it never happens that you need to downgrade because all migrations are successful. Of course. I mean, I never failed a migration in my life, believe me. And now, it's again the same issue. If you want to downgrade, kapiec. Doesn't work. So, conclusion, we need to make every change and break down every change into a succession of compatible changes, like backward and forward. And to illustrate that, I have a very, very simple use case. Imagine that I design an application and I design it at a later point in time, and now my application is very successful and I need to evolve my schema. And what happens is I really stupidly created a single table, and I want to break this table into two different tables. Never happens, right? So, I was an intern. I didn't follow my SQL design course, so I designed this person, which basically also has address information. And what I want to do is I want to break down this table into two different tables. Make sense to you? So this is something that happens a lot of times, and we can see it's not trivial. How do you handle those changes? Forward and backward. That's an interesting use case. So let's think about that. So let's try, as I mentioned, to break down those changes into different steps. So the first step will be I will create this additional address table, and every time I make changes to the person table, I will replicate those changes to the address table. And if I need to roll back, but that's fine, because actually the data will still be in the person table. Okay? Next step is to change the source of truth. So now the source of truth becomes the address table. And now every time I make changes to the address table, I copy the data back to the person table. If I need to roll backward my changes, the app will still use the person table, which has every data that I need. So it still works. Afterwards, I will stop copying the data and clean up everything. But at this time, you cannot roll back, but your tests will need to be make it clear that everything will be fine. And I don't know how many of you know are Java developers. Quite a few already. Spring Boot developers? less, but okay. So for the rest of you, I won't bore you with too specific details. Feel free to ask questions. But basically, if you are using Spring Boot, everything is automated for you. Everything is magic. Everything is fine. And we need to disable that, because otherwise, as soon as you deploy a new version of the application with a new version of the entities, then Spring Boot will try to update the schema. And as I mentioned, we don't want that. We want to manage everything. Fortunately, there are tools, at least in the Java world, and I hope also in other stacks, that let you like control what you want to do, and one of them is Flyway. There is another one called Liquibase, but because I know the guy behind Flyway, then I'm using Flyway. And if you don't know Flyway, you are working in the Java ecosystem, please, well, just use it, or use Liquibase, but use something. Because the problem with the database is now people are thinking about like code should be version controlled. Well, for you, it's probably implicit. Believe me, when I started working, it was not implicit at all. But the database is still out of the control of most version control tools that I know. So what happens if your database breaks? What happens with the data? What happens with the schema? What happens, whatever? You need it to have to have it somewhere, so you could like again like create it not from scratch. And this is the goal of Flyway. Flyway basically is based on something called a migration, and a migration is just a SQL script. So in the name, there is a scheme in the name, basically, which tells the sequence order, and Flyway will try to execute every script that didn't already execute. So basically, it will store in the table like the migrations that were executed. And if you already executed a previous migration for whatever reason, it will just skip it. So it will allow you to move forward. If you try to be smart and try to change a script that was previously executed, don't do it, because it also stores the hash of the script. So if the hashes, they don't match, it will like panic and stop doing anything. So it's also very smart. How could we run the migration? We could use something called the Flyway command line interface, which is pretty easy. You just write down. It's also very useful because for every migration, you could create an undo migration, so basically to roll back the changes. And this is like particularly usable with the Flyway command line interface. However, it's not automated. You need to write everything down. So in order to like do it in an automated way, if you are using Kubernetes, we could create a job. So let's create a Kubernetes job to use the Flyway command line interface and do the migration. Well, the problem with that option is, again, the job, you have no clue how to schedule it, when to schedule it. So there could be some issues that, hey, you thought that the job finished, but in fact, you started to deploy the new app and it doesn't work like that. To solve this issue, you could say, okay, then there is this init container stuff. Who knows about init container? Not that many people. Okay, so basically, init container is a great thing because you can write it down in your deployment, and then the contracts that the init container must complete successfully before any of the other containers start. So if your container starts, that implies that the init container deployed successfully. So you could write down in the init container, hey, I want to run this and this and this migration. It could work very well, but then you would need to change it at every new versions because you want to add new migration at every new version. So in that case, you would change your YAML file constantly, which probably you don't want. Another way would be to use Spring Boot, because Spring Boot actually has a good integration point with Flyway. So if you write your migrations and you store them in a specific folder, db/migration, they will be applied at startup time. Now the problem is if you have like 3 different or like more than one nodes that container. container. More than one container, they will all try to apply the migration. Well, it's not a problem because basically the first one that starts will basically lock the table, do the migration, and meanwhile the other, they will just like wait until the migration is done. Then it will release the lock, and the other will try to do the migration, and they will see that the migration has already been done, so they won't do anything. So it's pretty good. This is about like more code level stuff, so I try to be very smart and to try like not to use implementation details, but basically I had to use like Hibernate listeners. But anyway, that's very specific to code. Okay, let's do some demo. I've created an application that is like a normal Spring Boot application. I can already start it here, for example. And I need to go on the not the first version. Check out this revision. Then I will start the application, and you will see that why I was not a designer, but a developer. And this is the application, localhost 8080. Woohoo! I already have like one data point. I can add like more data points, whatever. That is just like simple CRUD stupid stuff. Really, really stupid. First thing is, I want this application to be like in Docker. So in general, people will say, hey, let's create a Docker file for that. If you are in the Java world, actually, I would really, really advise you to use something called Jib, which is a Maven plugin, which does everything for you. So you can decide which image you want to inherit from, which image you will create. And for example, here, at every compile phase, I will like move the result not to a Docker Hub registry, but directly on my local Docker daemon, so I don't need to store. So for like if you are if you want to do it on your machine, if you don't want to pollute your registry, then it will work very fine. And now here at this stage, I have created my migration. So basically, again, I create the person table. I insert one value just because I'm lazy and I just want to have already data in my database. And then I have my database, which basically is a H2 database. Is everybody like okay with this kind of object namespace? Do I need to explain it, or it's fine? Who needs me to explain it? Fine. Okay, that's fine. So basically, if you are using, if you are coding, you put everything into packages. You don't put everything at the root. Well, namespace it's the same. You want like your application to reside in different places. Then you can apply different permissions. So that's the goal of the namespace. Then, because by default, what happens in Docker, what happens in Kubernetes stays in Kubernetes. I'm also using service, so I'm able to access some ports, for example, the web app port from outside of the cluster. So this is the goal of like this service stuff. And I'm using H2. So because I'm using H2, I've created like one H2 container, and then I can deploy it. And this is the result. So here I can like connect, server connect. And here I have a brand new H2 server. I could use Oracle, MySQL, Postgres, whatever. H2 is like very easy for me. It's in memory, everything is fine. Next step is actually to create the application. So namespace I already explained, service I already explained, and now I have these deployments. I want three replicas, sorry, and I have this like image that I already created. So if I check here, Docker images. I already have those zero downtime with multiple tags, and now I want to deploy only this one. So I will, sorry? And now you see that I was hype before everybody here. You know, it's like when they ask you, like, how many years of experience do you have with React.js? We ask for 10 years. So now I have like a lot of experience with Kubernetes. No, actually, that's because I didn't. Well, by default, the Jib plugin like gives you no timestamp. So you can configure that as well, but by default, it's by default like that. And since it's just for demo, it suits me very fine. So now I want to like schedule the pods. So what I expect is basically here to have the schema created for me. And I will check that actually it does work, because if it doesn't, then my demo is failing, and that's never good. Oh yeah, it works very fine actually, very fast. So you see that it created the person, which is what I expected, and Flyway has created, it might be a bit small for those who are sitting in the back. Here is better. Here you can see that actually it has created the first migration. And now if I want to check, and I don't remember the port, not this one, this one. Good. So this is the same application. It's just that I scheduled it on Kubernetes. Here I am using the tag, so you can check which version it is. And here I'm using also the host name. So if you see it here, you can see this like W4 something is here. So this is this pod that I'm actually using. Now, I want the migration. Migration is actually, first I want to create the address entity, I want to create the address table, and every time I do stuff on the person, I want to copy the data to address. Okay? So I have this like new migration script, which basically creates the address table. And on the code level, there are multiple ways to actually copy the data. I could create a trigger in the database to actually, like, every time I do like a creation of a person, create the address. But I'm a developer, I'm not a database administrator, so I prefer to do it with code. And so, as I mentioned before, I'm using something called a listener. So every time I insert an entity that is of type person, yeah, the code is in Kotlin actually, then I will additionally like create the same address. So let's deploy it. And normally, because it's zero downtime, everything should be working. So here I will do watch. Here we can check that the application is still working on the old pods. And here we can check that, yeah, the migration has been passed. And after some time, you will see that here or here. So here I'm terminating one, but it's not the right one. Yeah. Yes. So seamlessly, I'm redirected to a new one. I will create an entity with this schema to show you that it still works. So I will create Jendu. Okay, this is still working. So we are at step like 1 of the migration, which basically is just stupid copy paste of person data into address data. So normally here, I should have in the address table, I should have one one line, which basically is just what I created. And it's related to person ID2, which is the person that I just created as well, Jane. Everybody is happy with that? Good. Next step. So the next step is actually now I will switch from the person as a source of truth to the address as a source of truth. And here I must handle the migration of the data because now address becomes a real source of truth. Before I didn't care, I just wanted the new stuff. Now I want everything. So I need to take the address of existing person and actually migrate them to address. So this is this line of SQL, and don't ask me exactly because when I wrote it, I looked at the documentation and I very fastly forgot it because it's just not my stuff. And now I want to do the same, so I want to migrate. I'm on version 2.2 and I want to apply the migration. And again, here, here, clear address, run. Here, it already copied everything, so now I'm just trying to just refresh. So here it redirected me to an old pod, because the existing pod was like restarted to a new version. And I want the watch stuff. Yes, 2.2. It's still compatible, so I don't know, I will create Clark Kent, which basically lives in the Arctic. And it still works. Now let's imagine, for whatever reason, I want to show you that I can downgrade as well. It will still work. I will just try to downgrade. So I need to find the application, 2.1. So no migration should take place. It should just like do the pods as I wanted them and just downgrade the pods to 2.1. So takes a bit of time for whatever reason. Yes, it's downgraded to 2.1. I can still create and it still works. I can still like do some stuff on it. And afterwards, I can like clean up everything and everything will be fine. So takeaways on that. If you want to have zero downtime on your CV, it's actually reachable. You can do it. You can actually do it. Don't listen to people who tell you, hey, just use Kubernetes and it will solve all your problems. Problem is not about deployment of the app, because we had Bluegreen deployments before. Problem is in the state. State is the database. I didn't mention the session there. So basically, you could use Hazelcast's session replication, for example, to just have like all the replication to all nodes in the same place, and it will be fine. But here I focus on the database. But state is in the session also. The problem lies in how you handle the schema changes. And so every time you have a schema change, you need to think how to design this possibly incompatible change into a succession of compatible changes. And this is where the cost is. And it has a cost because you need to plan for it. You need to actually involve your developers that will do the change. You need to involve the project managers that will need to plan how to do the migration bit by bit. You need to involve the ops people who actually will need to every time not do a single migration, but a succession of small migration. And so this is where the cost is. This example is not trivial, but it's pretty simple. Now imagine that you have, like, I don't know, 20 such changes because you have 20 features that all impact the database. You have feature branches. Imagine the mess it would be. Kubernetes won't help you with that. So just don't listen to people who say, hey, just use whatever. Here, Kubernetes is not at fault. It will be simple. Think about it by yourself, and you will see that there are a lot of problems everywhere. Though it's possible. So thanks for listening to me. You can read my blog, you can follow me on Twitter, and more importantly, you can get the source code by yourself and just play with it. So even if you are not in the Java stack, then you can still do some stuff, or perhaps you can implement your own using .NET or Node.js or whatever. And yeah, if you have any questions, now might be a good time. Thank you very much. It's always a bit frightening when there is no question. So either you are super shy. Okay.
Hi, my name is Yuri.
Привет, Yuri.
Привет. I wanted to ask about NoSQL storages, especially for document databases. Is the process of such migrations easier there, or maybe even more complicated?
No, it's exactly the same. It's a bit easier because then, I mean, it's the same. It's a bit easier because you don't have to have to think about the constraints, because yeah, you can put whatever you want. But the process of the application actually being compatible, it's the same. So the only difference is between like SQLs and NoSQL stores is most of the time NoSQL stores, there are no constraints. You can put whatever you want. Well, it's not schema-less, but it's schema basically when you read it. And some of them you can have like schema on write. If you are using Elasticsearch, for example, you can also have schema on write, but then you find the same problem. So the thing is, as soon as you define the schema, then there will be constraints, and you will need to take them into account. If you have no schema at all, it will be the same process because the application needs to be compatible every time with like both versions.
Thank you.
Thanks. Other questions? Вы скромные или голодные? Оба. Спасибо.
What will we have if, for example, we have a huge database and such migration can take a lot of time? And
very good question.
And after that, you can get
yes.
the not downtime deployment and some problems with database also.
So the problem lies, it's a very good question. Not this one, this one. The problem lies in this migration. So basically, this is what happens. You have your 3 nodes, v2.1 running, and everything is fine. Then you want to migrate, and you want to take all the data from the person to the address, and this might take a long time. So one like easy answer would be, well, don't have too much data. But of course, it's not always possible. The second way to look at it is, meanwhile, your other nodes, they are still using v2.1, they are still working as expected. So the real problem happens when the migration, like you are trying to take the data from person to address, but still there are some nodes that are still writing in address, and yes. And the answer is very easy. Again, this is the application that needs to be smarter. So in that case, every time you do like a read on the address, you should first do a read on the person to check if actually there is no stale data on it. And if there is stale data, which data is the correct one? It's not an easy problem. So that needs to be handled on a case-by-case basis. The good thing is, in general, you don't have one single table or two tables or one table that you want to split. You have a multiple of like different tables. And so imagine you have an e-commerce store, you want to do that. You can still let the person like order some stuff. You just, for some time, like disable the fact that he can change his contact details or his address. But that is very context dependent. So I cannot just answer with like one answer. I need to do more about. I need to know more about it. But I mean, you found a really real problem. I agree. And now there are like plenty of questions everywhere.
Yeah, exactly. So that was a really good question, the previous one. So I want to follow up on this discussion a little bit. So what you're saying for some like more complex scenarios, basically, where you maybe have a cluster or something, or a lot of data, you can't just do a switch from like code and schema 1 to code and schema 2 and expect everything would be good. You need like the step in the middle, where basically the code would be ready to work with like old and new schema, for example, and check what you're saying, like to check for the data, like to read basically two sources and compare them, kind of like that. And only then you can have a next step with like finishing your migration when everything is like in the like step 1 transition to step like 1.5 basically, and then you can transition to step 2, right?
No, your final state will be actually your final state. Will actually be checking the two different tables. That's your final state. And then you do
I mean,
like
this middle step, you're checking like two tables, and then when like migrating from like old table to two tables is finished, now we can start migrating like two table to new table basically, right? Okay, yeah, thank you.
Thanks a lot for an interesting topic. So I just want to add here that the Flyway would always open a transaction before applying a migration. So you should always take this into account. But the latest, I think, version allows non-concurrent updates, not transactional migrations.
Okay.
So some statements like create index concurrently in Postgres would actually work, but only with the latest Flyway.
Okay. So it's also very database dependent.
Yes, it is. But
because
like,
H2 is very basic, I'm not sure you can create concurrent indices.
Yeah, but I'm just saying that you use the latest Flyway to get more flexibility around those.
That's a good idea. Always use the latest.
Yes.
If you can.
But they changed the schema actually, so you should be careful.
Other questions? Well, I will be there the rest of the day, so if you have questions and you were too shy, just come to me and I will try to answer them. And meanwhile, prijetного apetita.